Welcome to Math Challenge 690. In Math Challenge 690, we have a semicircle diameter 10. A semicircle diameter 10 and a rectangle, part of it projecting outside. And you can see the midpoint. The height of the rectangle is divided into two equal parts at the point where it meets the circumference at which it intersects the circumference. So one vertex is on the circumference and the midpoint of the height of the rectangle is also on the circumference. The third vertex is on the circumference and the fourth vertex is somewhere on the diameter. And we have to find the area of the shaded rectangle. Area of the shaded rectangle. And although it may look tough, you might be surprised to know that all it requires is drawing three lines. If you can draw three straight lines, it will become very easy and even a class 6 or 7 student can do it. If we tell you or if you know where and how to draw three straight lines, then even a class 6 or a class 7 student can do it. It becomes very easy. All it requires is drawing three lines. Math Challenge 690, let us find the area of this rectangle where width is half of the height. You can see that width is half of the height. Let the width of the rectangle be A units, then the height will be 2A units. So width is A, length is 2A, and length is divided at this midpoint into two segments of A units each. So mark the segment lengths as shown. A units, and A units, mark the segment lengths as shown. Now we were talking about drawing three straight lines. The first straight line is the diagonal. You can see the blue dotted line, the diagonal. So draw this diagonal blue dotted line. So diagonal of the rectangle will be given by square root of length square plus width square, that is square root of 2a whole square plus a square, that is square root of 5a square or a root 5. The first line is the diagonal. Join the vertices, opposite vertices to get the diagonal, the blue dotted line, and the length of the diagonal will be square root of length square plus width square, that is square root of 2a whole square plus a square, square root of 5a square or a root 5. So mark this blue dotted line a root 5. So out of the three lines, one line was the diagonal. The other two lines are the radii. From the center of the semicircle, join the vertices. Join the vertices. So each will be a radius. So diameter is 10, so radius will be 5. So these two yellow lines will be 5 units each. From the center of the diameter, we are joining the opposite vertices which are on the circumference. So we get each of them will be a radius equal to 5 units. So the two yellow lines are 5 units each. Now the remaining part is very easy. Pythagoras theorem. Hypotenuse, the diagonal a root 5 and the two radii 5 units each. So using Pythagoras rule, a root 5 whole square is 5 square plus 5 square. Hypotenuse a root 5 and the two legs which are radii are 5 each. So a root 5 whole square equal to 5 square plus 5 square. Squaring a root 5a whole square, that will be 5a square, and 5 square 25, so 25 plus 25 50. So 5a square is 50, a square is 10, 2a square is 20, and the area is 20 because length is 2a, width is a. So 2a into a will be 2a square. The area of the rectangle, height 2a, width a. So 2a into a, 2a square. So a square equal to 10, 2a square equal to 20. So the required area is 20 square units. All it required was drawing 3 lines, 2 radii and 1 diagonal. And it became so easy to calculate the area equal to 20 square units. That was Math Challenge. Follow us for all school level math, junior and senior Olympiad math, university admission test, quantitative aptitude and numerical aptitude, and all competitive exams. And remember, all our services are entirely free of charge for students all over the world, so students from anywhere in the globe can contact us with their question and their problem. Like and share the video and subscribe to the channel and be with us. We will meet again with more useful videos, more interesting questions. Till then, thank you and goodbye.